Welcome to Wood Talk. Now here are three guys who like to take big pieces of wood and make them smaller. Mark, Shannon, and Matt.
What's going on, everybody? It's show number 558, and on today's show, we're talking about the current state of plywood, the new ribbit fence, and making stuff flat and square. But before we get to that, we want to let you know that Wood Talk is brought to you by Rockler. Rockler's been helping customers create with confidence for over 65 years. Rockler's giving away a $250 gift card to one lucky Wood Talk listener. Enter for your chance to win before September 30th at rockler.com/woodtalk.
And if you want to help support the show, you can totally do so. You can go to patreon.com/woodtalk and sign up to become a patron of the show. This time we're thanking no one. Good job, guys.
Yeah, nice. Way to support the cause, you turds.
Way to make it easy for me. Didn't have to say any names.
Maybe they just thought you were doing you a favor.
Just for that, Matt's going to pronounce them all correctly next time.
Yeah, that's your punishment, you guys.
Yes, that's it.
Meanwhile, Mark's been evil geniusing, master villaining with his cat in his swivel chair, stroking his cat. But it was such a friendly, welcoming tone, Mark. I needed more of at least a Dr. Evil.
Yeah, some kind of evil. That's the thing. I want to lull you in with a false sense of security, and then you'll find out about my evil plan. All right. Yeah. Well, let's get to the dining table topic today. All three of us have had, close encounters with plywood recently, and I think we can all probably admit it's not our favorite. I mean, Shannon, you're a hand tool guy, and in spite of that, you still plow into plywood like it's nothing. Mm-hmm. Matt, you're doing the kitchen cabinets. I'm doing Nicole's closet. Plywood is a reality for the moment, and post-COVID. It's maybe we could start with this part of the discussion. I'm not 100% sure if things have changed. I really don't use enough plywood to say, other than just from my personal experience, I'm having a damn hard time finding just good, reliably flat material. And it feels like it's a harder time than what I had prior to COVID and the material, shortages and then the price hikes. And I know industry-wise, Shannon's going to have a lot more to say about that, but we can go into a bunch of different things on this topic. But in other words, we're saying plywood, WTF. That's the topic today. So, Shannon, what's the story on quality levels? Is there an industry-wide quality problem, or what the heck's going on?
No, there isn't a quality problem. There is a market demand problem that certainly COVID exacerbated, and people say maybe it's an excuse now. But so there's a couple of things, and this is plywood and lumber in general. There's always been this kind of near inventory reserve, and COVID killed all of that because there was no production. All production was shut down. And when it comes to manufactured and engineered products, everything from plywood to OSB, it was completely shut down for more than a year. Pressure treated material was the same way. So that near inventory of high quality stuff wasn't just eaten into, it was eliminated completely. And the raw materials in order to make plywood, so the stacks and stacks of veneer and all that stuff that composes not only face veneers but inner core plies, that was exhausted as well. So when manufacturing started back up again for COVID, we were literally going back to the logs and peeling veneer and starting all over again. The problem was the building boom and the DIY boom and all the home renovation boom that happened when people were locked in their homes continued to drive demand through the roof. So when manufacturing started up again, the backlogs were so huge that the time that it takes to make good quality plywood was no longer available. It was, we're going to go to somebody else. And there was always somebody else who was like, oh, I can do it slightly faster, and plywood is a manufactured product. So I say this all the time on the Lumber Update. I've said it in the hand tool school. You can build the perfect sheet of plywood. If price is no object, money is no object, and time is not an issue, you can build a perfectly flat that will stay flat forever, no voids, all that. It can be done. But in order to meet certain price points, which is what the engineered market is all about, it's always about the price point, certain corners have to be cut. Do I dry the veneer uniformly? Do I peel veneers from only the finest logs? Do I roll the glue on a little bit thinner? Do I keep it in the press a little bit shorter? All of those things decrease your price point to produce and also your sale price point, but also your time to produce. So we came out of COVID with not a lot of raw materials. The raw materials we had didn't have time to season. and they just got pushed into the market. Well, at the same time, costs were going through the roof on solid lumber, everything was going through the roof. So we, as an industry, were able to produce slightly lower standard plywood at a higher price point. People immediately said, you're out of your damn mind. I am not going to pay $250 for that sheet. So what did the industry do? They said, okay, we can make a $180 sheet. We can make a $150 sheet. We cut some more corners to get there. So the market, and you can point fingers all day long, but if I go to China, if I go to Indonesia and I say, I want you to build a plywood panel for the North American market, they stop listening immediately. The North American market is so price conscious on plywood that most of the manufacturers in other countries, mostly the Far East, but also Europe, aren't interested in producing panels for the North American market because we don't like quality. In general, the world views North American plywood as crap because the North American market won't pay for decent plywood. So it's this mixture of things. The people that are making the really high quality plywood don't see the point in making it for the North American market. The North American market doesn't want to pay what it costs to produce that, nor do they want to wait for. Really what it comes down to is the logs, the right quality logs have to be peeled to create perfectly uniform, absolutely 100% clear veneers that have to be dried to 100% homogeneous dryness, 100% homogeneous thickness. The slight variation in thickness, slight variation in 1%, 2% in dryness causes a panel to cup. So all of these things, in order to make a perfectly stable plywood panel, everything has to be perfect. No grain variation, no color variation, certainly no knots, no voids, and 100% 0% moisture content, not just face veneers, but inner plies as well. And then it has even amounts of glue have to be applied, all that. So frankly, no, the quality hasn't slipped. People can still produce the quality panel that we had in the olden days, before the world ended in 2000.
Good old days. Yeah.
But people don't want to wait for it. People don't want to pay for it. So what happens? We produce what people will pay for. And the engineered material market has always been about the price point because China's sitting over going, well, we can make it cheaper. And the funny thing is you can go to a China mill and you can get an incredible piece of plywood, but it's going to cost a heck of a lot more. And what people think of Chinese plywood, no, it's got to be $50 a sheet. Now it's $50 a sheet. It used to be $27 a sheet pre-COVID. Now it's $50. They could make a premium panel that would be $380 coming out of a North American producer. They could make it for $280. But do you know anybody that's going to pay $280 for Chinese plywood? Not a chance.
No.
It's not going to happen. The market won't hold it. They won't support the demand. So what we're doing is essentially undercutting the manufacturers and saying, no, you have to reach this price point. Okay, we can do that. We can spread the glue thinner. We can use less glue. We can rush the drying time. I can use a log that isn't, AAA veneer quality. I can slice my veneers instead of peeling them. There's so many things that can be done to create a good panel, maybe even a great panel. But what is a great panel now sucks compared to 20 years ago.
Yeah.
So it's not an easy yes or no answer. It's a long supply chain issue and mostly driven by market demands and people already thinking plywood was too expensive before COVID and now just mad that it's even more expensive.
Right.
So yeah.
Matt, you're going through a lot of material now. Have you made any observations about the stuff you have or have any issues with it so far?
It's been pretty good. I mean, it's the C2 grade pre-finished maple is what I got. It was my first time actually buying plywood, I brought it from a wholesaler. Okay. As opposed to going to Home Depot and buying the birch ply for 50, I don't know how much it is now, but it was like 40, 50 bucks whenever I bought it last. These pieces were 125 and that was down from 165 6 months ago. So the price is better. As far as the quality goes, flatness is really good. They're like dead flat, don't seem to be moving even after they've been cut up and in the shop for a week now.
That's good.
I'm not seeing any kind of movement there. I have noticed a couple sheets have some failure of the face veneer. They're delaminating on the face. I don't know what's acceptable or what's common with this stuff. Right. I've never used it. I'm like, yeah, whatever. I just put it to the side. You're not going to see. What the hell do I care? It's a cabinet box.
Do you know who the manufacturer is? Any chance?
I can look. I don't remember off the top of my head.
Is the face veneer the same thickness as the inner plies?
No,
Probably
it's like
not.
the paper thin.
Okay. Yeah.
Stuff.
It doesn't ultimately matter. I'm curious professionally who's making it.
It's been something with the stuff that I'm getting where I'm starting, to question my own sanity on this and whether or not I'm just like my basis for understanding this is off. But I also moved to a different region and I have different suppliers now than I had before. So it's like when I pay $160 a sheet, I'm kind of expecting decent stuff. And when I don't get that, then I get upset. And then when I buy something that's like shop grade, when you buy shop grade, you know what you're getting into, right? You should not expect things like no voids and perfectly flat. It's not going to happen. But I do expect it not to completely delaminate. And that's what I'm noticing. It's like the bar has been lowered.
That stuff you got is weird.
Yeah.
I would be like, what the heck is going on?
That's what I would expect.
It's so far from what would be even like acceptable to any standard.
Yeah. That's like if I went to Home Depot and bought the cheapest stuff that's on the top of the thing, I would expect it to do what this piece was doing.
I wouldn't expect that from that either. Like that shouldn't be falling apart, just sitting there.
It's unacceptable. Like, even if it's low grade, it should still hold itself together for the most part.
I was laughing. I saw you gluing it back together. I'm like, what the hell?
That's when I thought I only had a couple.
They're like, oh, let me just, I can fix this. I got glue.
Yeah. I thought I had only two to do.
It's worse than I thought.
Yeah, much worse. Yeah. And then I got some Baltic birch, which, I mean, I realized there's different grades and different quality levels of Baltic birch, and who knows how.
Sale you bought?
Yeah, that whole thing has been flipped on its head anymore. But that Baltic birch was twisted in a way I've never seen before in like multiple dimensions. So thankfully that did kind of behave a little bit once I cut the drawer parts down. It was just the way it laid out. It was a reasonable amount that I could deal with. But on some of these other parts for the larger case pieces, I'm just like, man, what is this crap? Like, this is a real problem for 150
is it
plus
climate
dollars.
Where you're at or something weird like that?
I don't know. I mean, I'm buying it from a place that stores it in a similar condition to what my shop is in. How long it's been there, no idea. Or how recently it came in, I don't know. But then I did some like very informal polls, and look, I mean, you do a poll online, you could find people to agree with anything.
Yeah, right.
Especially now. So when I'm like, hey, plywood sucks, doesn't it, everybody? And they're like, yeah, it sucks. And I'm like, I don't know that that's a real good scientific poll, but it seems like a lot of people do agree with me that things have gotten worse. Yeah. So that's kind of where my question came from.
The irony is, and in my head, I'm backtracking, region to distributor to manufacturer. And Mark, it seems to me you should be getting better plywood having moving further east.
Right, rather than super dry Denver.
Yeah, well, and also where your plywood is coming from, Rocky Mountains West, it's coming from different manufacturers, and like assuming they're North American panels, but like the long, massive heritage, like well-established plywood manufacturers tend to all be out here on the East Coast. And you've got really, really high quality stuff that's coming, where some of the newer guys, the young 100-year-old upstarts, that's really what we're talking about. They're out west and they're supplying some of that market. And plywood is one of those things where it doesn't really make sense to stick it on a rail car and move it, across the Mississippi. But you being east of the Mississippi, wait a minute, no, you're west of the Mississippi.
Oh, no, I just live here.
No, you're not. Whatever.
Where's that river?
Where's that river? It's over there. You still should be getting. Doesn't matter. It's all just ironic. I think what I always say is, and this is the same with solid wood, like furniture makers are such a small minority. We don't have any power to affect industry because we comprise such a small percentage of overall business. When it comes to plywood, that's even more so. And the demands of the furniture maker, even built-in's a slightly different thing. Demands for plywood are so much more stringent for freestanding furniture than 99% of what plywood is used for. Most plywood does not need to be stable, as in stay flat, because it's nailed or screwed down to a substrate. To me, the gold standard of plywood uses is the marine industry. And that's because of just the water, like the waterproof nature that's required. In order to get that waterproof nature, the byproduct is a really, really stable panel. But it's truly ironic because the first thing they do with that is screw it down to a substrate and then fiberglass the crap out of it. Whereas in like architectural millwork, where you're looking for full panels and things, it's all screwed down to studs, which, as we learned from Matt's house, was never flat, was never plumb, was not all on the same geometric plane, so it's screwed into submission. Whereas furniture, like if you're building tall K-sides and things like Mark's building, even then there tends to be a structure. shelves and things like that, aka torsion box inside those outer things that everything gets attached to. Smaller furniture, like cut down to 4 foot, or cases like cabinetry where there's a lot of plywood used. Your average wall cabinet is 18 deep, maybe 36 high. That's a small piece. And if a panel is a 4x8 panel is out of flat, the fastest way to flatten is to cut it into an 18x36 piece. Tends to be a heck of a lot flatter at that point. And then you screw it or domino it if you're Matt into, a fixed interior shelf, which as long as your cut on the end of the shelf is flat and square, you're going to pull that case side into square. Then you're throwing a face frame over top. You're putting a back on it, which is pulling the whole thing into square. So plywood, normally as we build, doesn't need to be flat. Now it needs to not delaminate. I will take exception with that, Mark.
Yeah, that would be nice.
And that's why I think when people, and I'm going to take like the opposite side of Mark's poll, where everybody's like, yeah, plywood sucks. I tend to believe that most people put plywood, like their expectation is too high. Like what you want it to do, to expect that panel to stay perfectly flat over a 4x8 span is nearly ridiculous. And if you actually want that, do not expect to pay less than $300. I can make that. Well, I can't make it, but I can find someone who can make that for you. Yeah. But expect right now $350 to $380 for a sheet that will stay dead, air quotes, flat over a 4x8 span.
So when it happens though, which is not like it's never going to happen, when you do end up with that batch of plywood that is nice and flat, is that simply the exception to the rule? Is it just we're getting lucky, or you know what I mean? If you're not paying that much, it happens. People clearly are. In fact, the contrast to what I've been getting, we went to a different supplier, and because the other place ran out. It's a little bit further away. Jason ran out and got a bunch of sheets of this, and it was so flat. It was like, oh my God, this is perfect. This is what I remember. So I'm like, I want to make sure we go back and get that exact stuff again. And that's what I'm wondering. Like the way you're presenting it, it's almost like we got lucky with a good sheet at that price. Like that sucks if that's the case.
I mean, that feels a lot more of like a crapshoot. But the problem is you can go back to that place and you probably won't have the same experience.
Right.
Same product, same price point, same distributor. Because again, just know I'm going to say that all plywood manufacture is almost entirely automated. There's some sorting and grading of sheets, but like the other thing is things like delamination, a lot of that doesn't show itself until quite far downstream.
Oh, yeah, sure. I didn't see it until I started cutting drawer parts.
Right. You can actually eliminate glue entirely from the manufacturer run, and the panel will still hold together because the heat and the pressure that the panel is pressed under will actually cause it to laminate, like almost heat weld together. And it will be like weeks down the road where it will begin to delaminate as it actually dries out. So like the moisture that's in the air in the factory is causing it to glue, just like you can wet two pieces of paper and they'll stick together until it dries out and comes apart. So like if the glue, and I've heard many stories, and I've had my plywood buyers travel all over China to look at this stuff. And he's like, the glue pot like ran out and no one caught it for like 6 hours, but the mill was still running. But the thing is you couldn't really, like you could go, well, it was from this time to this time. We can kind of get an idea. And they recalled that run, but there could be like 300 sheets on either side of that window they pulled that made it through that they don't know. Or as the glue plot was running out, it didn't just like, glue on one sheet and suddenly no glue. It got thinner and thinner and thinner. So then you've got shades of gray on how much glue is used. So that delamination might occur in 2 weeks on one panel and 3 months on the next panel. And that was all in one run. And if that factory is producing 4,000 sheets a day, you can only imagine, like, by the time it makes its way down to your retailer, like how many sheets did they buy? And did all those sheets come from the same production run? I highly doubt it. It is kind of a crapshoot. And when you get that, that's why you get these examples where one guy's like, best plywood ever, buy it from this guy. And the next guy is like Yelp reviews for restaurants, right? This place was awesome. This place sucked. This place was awesome. This place sucked. And they were all there in consecutive days. It's like, apparently on Mondays it's awesome, but on Tuesdays it sucks. But Wednesdays it's great.
To your point, the 3/4 inch that was really good, the same place was where we got the delaminating 1/2 inch from.
Yeah. Yeah.
Obviously it's a different product, so it is what it is, but the same place is capable of selling crap just as much as they're capable of selling the top-notch stuff. So
right. And there's so many variables that come into making a perfect panel.
Yeah.
All the way back to where they bought their logs, who they bought them from, who did the grading of the logs, how thick or thin did they peel it, did they guillotine slice it, etc. It's maddening to try to buy it. So my solution to this is learn to build around it, frankly.
All right. Well, let's get into that exactly. I wanted to talk about that. So let's take a step back. You're bringing this stuff home and see if we can give any guidelines to what might help people have better success with this. So if you bring that plywood home and it's now in your shop, you're not going to be able to get to it for a little while. You're in your Matt's situation. You got a big project and you got a bunch of sheets sitting around. What is the best way to store it to promote it staying flat for as long as possible? What would you recommend? Because I'll tell you, for me, just being realistic, whatever you're supposed to do, I probably don't do it. Like, I'm going to bring it in, I'm going to lean it against my planer until a couple days go by when I'm ready to use it, and hopefully it's still flat by the time I go to use it, right? Most of the time, that's what's going to happen.
Sounds like it being your way.
Yeah,
it is. And that's what forces me to finish the job so that I can get the damn piece of plywood out of my way.
Well, I can tell you the only way you can store plywood and expect it to stay flat is if the same way that Matt air dries his lumber. Like, it has to be a perfectly level, solid support throughout, probably more support, more bolsters onto the plywood than Matt's putting under his lumber, because plywood is inherently not rigid. Structural properties of plywood suck compared to solid wood. Solid wood is much stiffer, much higher modules of elasticity and modules of rupture than plywood, unless you were buying lumber core or stave core plywood. And the whole reason lumber core plywood exists is because it's a more rigid panel. So like ultimately, Mark, like you're doing built-ins, which ultimately can be screwed down to a wall. But say you were building that closet to be freestanding, I would use lumber core plywood. If you're building a 8-foot tall bookcase, use lumber core plywood, because by itself, plywood is quite flexible. Whether it's bending ply or non-bending ply, the stuff is not rigid. So if you lean it against a wall, it's going to sag into whatever that is. If you lay it down on the ground, but you don't have adequate support, and I would say probably 16 inches on center at minimum, and now those bolsters need to be perfectly coplanar, on all level, and then you probably should put some weight on top of it. In other words, there's no way, unless you have like a whole separate barn.
Sounds really familiar.
Yeah, right. It sounds just like your lumber stacks, because
sounds like stacking slabs.
Exactly the same. It's exactly the same. And it is solid wood that has the added complication of vapor barriers between each ply called glue. So it's acclimating, and it's cross-grain situation. So how is it not twisting? How is it not turning?
It's a miracle it ever stays flat.
Exactly. So the only way to do it is how Home Depot does it. They stack it flat and they ratchet strap and steel band the crap out of it, and it restrains it flat. So, and you take the band off and everything looks good, but then it just starts to move.
And also why you don't want the top sheet most times.
Yeah, generally. So I think that in many ways, plywood is a ticking time bomb. It's going out of flat like your car. It's losing value the minute you drove it off the lot. It's going out of flat. So probably your better bet is to, like, if you bought it for some reason, you probably want to cut it down closer to size while it's still flat. But then expect that it will go out of flat like along the way.
Well, you hopefully get it locked into a conformation in whatever you're building, so that if it does decide to move, it's got to fight something else to move. So it mostly stays flat.
So there's two sides of that. You can either cut it down and you've reduced it in size and there's less torque and stress, so maybe it won't move nearly as much, or you cut it down and you lock it in place as fast as you can. So maybe you leave it. But see, and this comes down to manufacturer. Like most people using plywood are using power tools, unless you're weird like me. Then it becomes an issue where if it's slightly out of flat and you put it on your table saw or you route a groove, the groove is not the same depth throughout because the panel has a cup to it. Or the CNC cuts off because it's not laying perfectly flat on the bed. To me, it ultimately always comes down to altering your construction methods. So the big CNC machines now have those like air hockey table bases that suck it flat to the to the bed. They expect the panel to not lie flat. So they suck it flat. And then, they route it from there. Now, the problem there is your panel not flat as in cup, but not wavy? Is the face, at least if it's cupped, it's not like waving along. It's generally flat in that dimension. So that when you suck it flat, you still have consistent thickness throughout. That's where you're spending money. If you're a CNC place, you're not worried about buying a perfectly flat panel. You're worried about buying a consistently thickness panel because you can suck it flat. And that's what we should call this show, by the way, Suck It Flat.
I mean, you're saying it enough. I don't see
Right?
that we have any choice.
So then your CNC is at least cutting on the the zero, the 0 point is still the same. So I honestly think there is no storage solution, Mark, finally getting to your question here.
Yeah.
Just plan for it not to be flat.
So then if we're planning for it not to be, there are a couple things that I can tell you what I do just habitually with plywood builds to help things line up the way I want them to. In some cases, you got a face frame or whatever, you can get away with things not being perfect because the face frame establishes the visual squareness of the final piece. It's just one big illusion. If you got a little bow on the inside, it won't make a big difference. But there are times where I really want to minimize that because it's very frustrating when I go to put these things together. And because I got a big cabinet side, or let's say I'm doing a bookcase, that thing's bowing out. I don't want that thing to be not perfectly, two sides not perfectly parallel. I want them to be even. A couple different things that I do personally, and I mean, if you guys have other tips that you do, please let us know. So for me, dado depth is a big thing. When I'm cutting dados into plywood pieces, sometimes whether it's hand pressure or the panel is maybe cupped or bowed a little bit, I may not get a perfectly even depth across that piece. And if it's not a perfect depth, when I go to, let's say, sandwich a shelf in between those two dados on two sides, I may not have this consistency that allows for me to just kind of lock this thing into square. So if it is inconsistent, you tend to like bow out that side a little bit. Maybe it sort of presents as being too long. And then I got a bowed side to the cabinet. So one thing that I do, and this is where the whole goofy hybrid woodworking stuff comes in, I'll take a router plane to my dados to make sure they are all an even consistent depth. Now, if you can get it perfect off the table saw, great. But if not, that's a great way to make sure that they are all equally deep. So then if you have a series of these things and you're clamping from side to side, when you clamp it home, that's as good as it's going to get. And it should straighten out and flatten out, hopefully. So that's one trick that I do repeatedly. Similar thing with a drawer bottom. It's sometimes getting those drawers to sit perfectly. If they're not straight, I'm dealing with it right now. I've got like 10 drawers to glue up. Some of the pieces just aren't flat. But if I cut my drawer bottom, it's a plywood bottom, so there's no harm in that thing being exactly the size that it needs to be. I will go through the trouble of painstakingly making sure that it's not only a perfectly square panel, but it's the exact dimensions that bottom out in the grooves in my drawer sides and front and back, that when I clamp those things down, it's got no choice. It's basically going to be flat for the most part, unless it's a really tall drawer. It's going to flatten the pieces out, and it's going to make sure my drawer is square. So those are two things that I thought of off the top of my head that like I always do on pretty much every project to make sure that if the plywood's misbehaving, the project doesn't care.
Yeah.
What about you guys?
It's actually a really good point to think of the female side of the joint, because most people are like, my end cut on that shelf is perfectly square.
Right.
Why is, and people are like, I checked everything, it was all square, and then when it came out of the clamps, it was the same out of length. Square. Yeah, right. You've done all that. It should
be fine.
But thinking about the groove depth and the consistency, and because plywood is inherently bendy, it's not rigid, you can clamp a concavity into the side of your case, or a convexity, because especially the center of that dado is slightly shallower than the outside. That's actually a really good point. For me, it's structure. I plan on the outer case just to be a suggestion. I'm building a case right now that's a series of cubbies, and I built the outer case first in order to capture my inside dimensions. But what I focused on was the inner grid, getting that grid spot on. So to Mark's point about the drawer bottom, if I can get that inner grid spot on, then I can use that as my clamping aid. And clamp the outer point to it. So at the same time, that inner structure, in my case, it's a grid, so it's like a torsion box, but I'm relying upon that internal structure to add the stiffness that does not exist in plywood. So why do we put backs on cases? Because it looks pretty? Well, sure, but a case itself is inherently going to rack. But if you put a back on it, it will hold it square. But if the back you put on is 1/4 inch plywood, like cheap IKEA furniture, the case is still going to rack. So do things like build a really solid case back, do a frame and panel case back, or do a solid plywood case back, and do like Mark said, make sure that case back is dead on square. And if when you fit it into the case, it's like, oh, this isn't work, your first thought may be, oh, let me grab a block plane and trim down my case back. Well, what's going to happen, it may go together square, but it's going to sag out of square over time. So you want to build to support it. If you're building a plywood shelf and that shelf is kind of sort of long, maybe more than about 30 inches, it's going to sag. So build like a thicker front to it and like turn a board on 90 degrees and like lay the front in so that you're essentially adding bracing to the drawer front or to the shelf to keep the whole thing stiffer. And that's what I say, build around it. Inherently plan on your plywood to not be flat, but also recognize that plywood is quite flimsy. It's not really a structural piece. So add structure with whatever else you're building it from.
Okay, so Matt's leaving. For anybody watching the video, he's got to go pick up his daughter. And we will continue, somehow march on without our little buddy Matt. So one other thing, bye little Matt. One other thing,
he's back. My local.
Yeah, go ahead, stop your local.
Stop.
Matt's
okay.
Goodbye.
So, bye.
Bye, man.
One other thing that I do, boy, he left his stream running too. I hope no one comes in and does anything weird.
We're going to find out. I'm going to keep it up.
Yep, we are. Okay. So one of the other things that I do that I've found can help, and you got to watch out for this. Let's say you're doing 2 bookcase sides and they each have like a little bit of a cup in them. One thing you got to be careful of when I talked about doing the dado depth and being able to squeeze in, it's really important to understand the orientation of the faults that are on these things. So if you have a cup, which way is the cup going, right? Because here's the thing, if you have 2 pieces, 2 bookcase sides, right? Both of them are cupped the same way. And those who are watching on YouTube, you see my very accurate hand model here. They're both cupped the same way. So then I put my dados on the insides. So I'm going to dado here and dado here. And then when I squeeze together with a clamp, I'm super excited now because I know I'm going to clamp that bow out, right?
Right.
No, they're the curve's going in the same way.
Right. Now
so
you've got a half moon shaped case.
I will have 2 out of flat sides because they are in unison with each other. So if you do see that and you have the opportunity to do it, try to reorient those pieces. When you cut those dados, put them so that the faces, the curves oppose one another. And then when you clamp in the center, if they're both bowed out, then you have an opportunity to straighten it out a little bit.
For those listening, imagine 2 parentheses, both facing the same direction. Mm-hmm. You know, that's what Mark's talking about. You want your parentheses to face opposite directions, like you would actually use them.
Right. Well, think like one butt cheek of a parenthesis emoji butt cheek.
There you go.
Yeah, you know what I'm talking about, right?
Exactly,
Just one butt cheek.
Exactly.
So yeah, I mean, there's a bunch of different tricks. I would love to hear from you guys if you use plywood, if you know of some cool little tips and tricks that help you navigate around this stuff, because it can be a real pain in the butt if what you're expecting is dead flat. And you know, from Shannon's description, it sounds like we may not be able to expect that, which is why even before COVID, I would be unpleasantly surprised sometimes where I go, well, that's not flat.
Right. Yeah, and I think things like, I mean, you can look at a sheet of plywood on edge and you can generally see like it looks fine. And then you start cutting it, and that's when the voids show up. You know, if there are visible voids on a factory cut plywood, 4x8 sheet of plywood, if there are visible voids there, you really shouldn't be paying more than like $30 for that sheet. That is a really low grade of plywood. The voids are always hidden on the inside. I shouldn't say hidden. That's just the way they're designed. The voids and the piece together, because voids really happen because you're taking separate pieces and, you know, glomming them together. You don't have a full sheet or whatever. But as you start cutting into that, you're going to start uncovering those voids, and then all that built up tension or lack of tension is going to make it even wonkier. So one thing you can count on as you're cutting your joinery is voids are going to cause like tearing and thinner sections in one area than another where you've got less material because there's a void there. That's going to cause that thing to go out of flat. It's going to cause greater swelling because you've got more in-grain exposed. When you put glue in there, you could get, you know, people talked about using biscuits and it would cause swelling. You could see the biscuit. It's the same thing that's happening here. If you have a void, that's going to be a pocket that's going to hold more glue and more moisture, which is going to cause that plywood to swell. So you'll get like little dimples on the outside because there's been more swelling there. But here's the other thing, like if you sand that dimple away, that moisture is going to drop and then you're going to have a recess in the same size.
Right.
So yes, plywood, air quotes, doesn't move, but you have to remember it's still wood and it still has to acclimate. It's still got tension. It still has swelling that may happen when it's been cut. So don't think of it as this perfectly immovable substrate that you can throw all wood movement out the window. You just have to think of it in a slightly different way. And it's also still prone to absorb moisture and shed moisture, just like any solid wood would be.
Sure.
So yeah, build accordingly. And the biggest takeaway, and I've said it like 17 times already, is it is not strong. Structurally, plywood is crap. So don't treat it that way. Imagine you were building everything out of like 1/4 inch thick, hard, solid wood and build your internal structure like that, and you'll be better. You'll be better off.
All right. Well, hopefully that helps some people and maybe answer some questions for, it did seem like a lot of people were really upset about the current state of things. So maybe this is a way to get around it, but I do hope quality improves. If that is a thing we're actually seeing right now, I do want it to, you spend $150 on a sheet. I feel like you should get pretty good material, but that's not happening.
Yeah.
Okay. Well, if you want to learn some great plywood building techniques, you know where you should go for that?
Not here. Well,
Correct.
I don't know. We had some good techniques. I don't know. Maybe
we actually
Rockler.
did.
Don't go to Rockler this time. Tune into Wood Talk, episode 558.
You might want to listen to this show. Well, if you're ready to learn more about woodworking techniques, Rockler classes and demonstrations can be an exciting step in the right direction. Presented by members of Rockler's friendly and knowledgeable staff or special guests, these in-store sessions have something to offer woodworkers of all skill and experience levels. Topics range from wood turning, cabinet building, finishing techniques, working on a CNC, and many more. Visit rockler.com to find a store near you. You could sign up there. And if you don't have a local store, check out their website for educational resources, including videos, articles, and free step-by-step project plans. What a great resource. Go to rockler.com.
Yay,
check
Rockler.
it out. Yay, Rockler. I kicked Matt from the call. Hopefully that doesn't mean that I lost his video for YouTube too, but we did most of the talking this time, so maybe it'll be okay. Okay, so we've got 2 more questions to round out the show. I'll take the one that Matt was going to do. This one's from David the Dog Trainer. He says, you may have seen this already, but I thought it would make a good what's new. It's a table saw fence that has a computer-operated adjustment. Their claim is that it's bringing more accuracy to the table saw, similarly to a CNC. Love to hear your thoughts on it. I personally have 0 thoughts. Just interested. Well, it's not many people will just admit that. I got no thoughts on this.
I got nothing to say on that. Thanks.
I got nothing. All right, let me go look at the video just to see if it's the same one that I saw, because I believe it is. This is on Frank's page, right? Yeah, that's what it is. We'll put the link in the show notes if you guys want to check this out. It was on Frank Makes, has a great channel with some cool stuff. This is a motorized fence that's supposed to be really, really accurate. Super cool. The thing I'm going to say about this is, doesn't this already exist? And I'm not saying that from a place of knowledge. I feel like I've seen this, and maybe I'm thinking of the one that's for the miter saw. Isn't there something called like a tiger stop or something like that? Hold on, let me look that up.
I don't know.
Really should do some research before doing a show.
It certainly exists on the industrial level.
Okay, Tiger Stop is exactly what I was thinking of. So, but I think that one is dedicated to a miter station, if I'm not mistaken. Let's see, Tiger Fence. And they definitely do more industrial stuff as well, this Tiger Fence place. But it seems like something that should be adaptable to a table saw if they don't already have it. So I'm kind of speaking out of turn here because I wish I looked a little bit more at Tiger Stop's product line. Anyway, point was, when I saw this, I wasn't like, oh my God, I've never seen this before. I felt like I saw it before, but maybe I'm wrong. Maybe this is the first one to be applied to the table saw.
I don't know.
I don't know.
I still have to look at it and go, do we really need this?
Yeah.
I just know me, and back when I was working with the table saw, I would set the fence and then I would double check it, with a ruler, right up to the blade, not the body of the blade, but the edge of the brazed carbide, and then I would make a test cut, and then I would check that the test cut was the right, dimension, both the front and the back, to make sure there was no run out in the blade and all that fun stuff. And I never really got to the point where I trusted my machinery enough, and maybe that's just my problem, but I feel like if I dialed it in, I suppose if you did it enough, you'd be like, okay, this machine is super accurate, and more importantly, super precise from time and time again. It's giving me the same thing, and you just learn that you can trust it. But I just don't feel like I would ever really get to that point, and I would continue to be pulling out the ruler, and which is even stupider now because as I've gotten older, like, can I even trust my eyes now?
Yeah,
you know,
right.
So yeah, I don't know. I just don't know that there has to be a place unless you are mass producing like 100 different parts on multiple days, and you need to make sure that the fence setting yesterday was the same as it is today. I don't know that it really makes a difference. Set it once, run your parts, and don't move the fence.
We live in a world now where like everybody and their uncle has a CNC, you know, so we've got these automated things coming into play. Something like this that we would envision as like, well, it's kind of just a toy, you know, like, and I mean toy in the good sense, like it allows me to do the thing I want to do, but do it better and more accurately. Yeah. A lot of us, if the funds are there, you go for that stuff.
Now, if you're slaving machines to your CAD program, so you can not only have your CNC cut your joinery, but then like send it over to the table saw and the fence is already set for that part. So you click on part A and zzz, all the machines in the shop kind of come into line. That's kind of cool, but that's a little also scary.
There is something to what you were saying where I've experienced this at the miter saw, for instance. I have Woodpecker's little, what do they call it? The little flip stop deals that kind of hide into the surface. Yeah. There have been times where I would make a mistake and I need to go recut a part. But the stop that I had, because it hides away and it gets out of the way, I didn't have to reset the stop position. I just ducked it out. And then I could go back and it's still there. So same thing with my planer being digital now. If I mess up a part and I need to go back and it's just, look, does it have to be dead on accurate the same as the other parts? No, but does it make my life a whole lot easier if it is?
Yeah,
yes.
True.
So
that's true.
In a similar way, I could see this being useful also having an employee. Not that Jason can't read a tape measure, but he may read a tape measure differently than I will read it. So if I say, hey, cut this to 1.5 inches, his 1.5 might be slightly different than mine. And it would be nice to have something to dial that in. Now, here's the thing about this. I did look at this while you were talking. The Tiger Stop, that brand does have something called the Tiger Fence. And that is something that is added to a table saw. Here's the thing about it. I think it's like $4,000. Somewhere on here, I saw a price. Where the hell did it go? I got a chat bot. I could use that.
The fact that it's hard to find tells you it's expensive.
I mean, it is really, really fancy, though. This one is like, this is hardcore. Okay, so the Tiger Fence is $5,175. So this is not, the average Joe picking up something like that. Looking at the Rip It product, which is currently a Kickstarter. I'll put this link in the show notes, Shannon, if you want to put that in our notes that we post. Where the heck is it? There it is. Okay, so if you go there, you can actually back this project and you can get, let's see, the special Rip It Fence Early Bird Special, $1,049. So very, very different price point if you're just looking for that basic functionality. So maybe that's the key. Like, again, my brain said this thing already exists, but it didn't exist at this price.
Right, yeah.
At $1,000, you find that the well-off hobbyist is probably, going to consider something like this, potentially.
Well, and I do think that the hobbyist, like, I am so not the target demographic here. So my doubts make perfect sense. But the person who would see value in this is going to be someone who probably already has a fair amount of automation built into their shop already. Yeah. And this would be beneficial to them. So yeah, they've probably already spent, multiple thousands of dollars on other machinery that dropping $1,500, $1,800 on something. Yeah, it'd be fine.
Well, it's interesting, man, because as being someone who really was brought up on relative dimensioning, which I think is the foundation of a lot of great woodworking, including your woodworking. It's not so much like, your whole thing is draw a line, cut to the line, right? And then the next piece you make has to fit between those pieces. So you draw a line and you cut to that line. That type of cumulative building process that we often call relative dimensioning, that works great. But there is also something to be said that knowing that your pieces are dead on to what the theoretical number should be. So if I'm cutting my parts to 3/4 of an inch, knowing that my planer truly does produce perfectly 3/4 inch material actually is a bit of a game changer for me in the way that I work through a project, because now that I can count on that being 3/4 of an inch, imagine if I had a table saw that cuts another part to exactly 14 inches and I'm putting that between those other pieces. Well, now I know that my total length, including my sides, is an exact number. It's a weird way of not weird. It's a more accurate way of building, and I would say more predictable way of building. It's not right or wrong, but it does invoke a different type of building strategy that I've started to dip my feet into, where I pull out the calipers more often now than I used to, like a Daryl Peart style woodworking.
Nice.
Very analytical sort of way of doing it. So
well, the other way of thinking about that is also, it's not really something you do halfway. All of your machines need to be relied upon in that respect.
Yeah.
If I've got my, let's use the table saw. If I know my table saw is cutting 14 inches every single time, but I don't know that every single board, is of the same dimension or the perfectly square edge or any of that stuff, that's where things start to break down. So it is a highly accurate, but also it relies upon precision throughout the entire shop. You can't half-ass your planing and expect the table saw to make up for that. That's...
Yeah. Well, I mean, it covers one part of the process. It definitely gets more powerful the more of those kinds of things you have access to in the shop, for sure.
It's interesting.
All right. You want to grab that next question?
Yeah, this question actually kind of dovetails nicely into the entire thesis of this thing, both from Plywood, but then also this precision thing. Jordan says, I'm a new woodworker. I cut my first piece of wood ever last November, and I'm a new listener. Hey, welcome, Jordan. Welcome to the obsession. Thank you for laboring to create such an enjoyable show, and thank you for not taking the criticism as discussed in episode 534, because this show is awesome, inspiring, and hilarious. So thank you for that little thing. That has nothing to do with this question, but it was praising us, so I had to read it. He says, my question is, what are some simple beginner-ish tips and recommendations to making and keeping my project square, flat, and level? So the points that Mark just talked about in Plywood when it comes to making sure your joinery is of consistent depth throughout, spot on. That type of thing is excellent. But I like to look at this from more of a systematic approach. And here's a little shameless plug. I actually have a lesson that's individually for sale in the Hand Tool School for $10 called Casework Accuracy.
No ads.
Well, yeah, sorry, I'll sponsor the show. I'll go and become a patron in order to get that in there. But the whole principle, and by the way, you can go pay for that lesson, or you can just keep listening, because I'm going to tell you what's in that lesson right now. The idea, I think of any piece of furniture, but especially casework, because casework, it's important to be square, right? If you're building a chair, it may not be as important, but anytime you've got like a drawer, a box that has to fit within a box, or more importantly, a box that has to fit on like metal drawer slides that fit within the box. Not only does the box have to be square, but it needs to stay square, because if the case warps, then those drawer slides don't run so well anymore and they start to rack and everything. So I like to think of it in terms of variables and constants. A case has two sides and a top, so 4 different parts. But if you can mill those 4 parts to the exact size you want and join them into a case that is square, and you can join them together, now instead of having 4 parts, you have 1 part, and that 1 part becomes a constant. That then, like Mark was talking about earlier about relative dimensioning, I now know the inner dimensions of that box. So I can size all my interior parts, all of my shelves and things like that, from those inner dimensions. It's the same reason I would never build the drawer first and a case second, or I usually will build the case and then the doors later, because I can set that constant. That outer case is now my constant. So the big thing that I'm saying is as you're building, you want to try to lock in. Like, I get that dimension. I've measured that board. I've checked that board is square. Then I've joined it to another board and I've checked that those are square. But if it's dry fit, that may be square, but when you apply glue and there's a little bit of swelling and then you apply clamps to it, especially with the clamps you can buy today that apply 3,800 pounds per square inch of force, right, you can clamp an assembly out of square. So never assume that because the end of the board is square and that those 2 joints that went together are square, or that the dry fit is square, that the resultant part coming out of the clamps is therefore square. So you're going to constantly be checking, to a somewhat obsessive point, always be checking that things are staying square. Because like we talked about in our last episode about compounding errors and miters, these little things creep in. And generally what happens is somebody comes to me, like we get emails all the time saying, I did this, I did all these 9 steps, and now my case is out of square. What gives? And it's like they checked at those 9 steps, but they didn't check. They checked step 1 and they checked step 2, but they didn't check the result of step 1 and step 2. Right. Each individual part was checked square, but they didn't check that when they joined them together, they ended up square. So you kind of want to be constantly thinking, every time I join 2 things together, can I check off that those are now perfectly square. And if they're still not a constant, if there's still two variables that need to be joined into one constant, never trust it. So I'm constantly trying to eliminate variables and turn them into constants. So turn 4 pieces into 1 piece. And that's basically the core principle in everything that I build. And that way, when things do go out of square, well, you can say, well, I knew that it was fine, and that's why I created a constant over here. So the problem must have happened between step 4 and step 5 because I was joining 2 constants together. Does that make sense? Am I using too much?
It does. I think another way to look at it, another language or terminology I would use for that is subassembly.
Yes, exactly.
There are times where, let's say you're doing, I don't know, a desk and you got legs, you got cross rails, you're going to have long rails to join the 2 side rail assemblies. So the sides tend to be one of those things you would do ahead of time, right? So I'm going to take two rails, 2 legs, glue those together. That's my right side. 2 rails, 2 legs, glue those together. That's my left side. Yeah. So once those are glued together, they're not moving anymore. So this concept of the constant is something that in my work, I would probably just call a subassembly. And once the subassembly is together, that's a new single reference point that then dictates the next stage. Right?
Yeah. And I think the way of looking at it that way is assemblies and subassemblies is if that glue up becomes daunting, and I guess UPS is at my front door because Kenny's going nuts as usual. Can't be a wood talk without Kenny losing his mind.
Right.
If that glue up is daunting because you've got so many different parts, look at it this way. If you're worried about open time on your glue up, break it down. Like do a subassembly.
Oh yeah.
Because if you're worried about glue curing, then you're going to rush, which means you're not going to check that things are square. And to Mark's point earlier in the plywood discussion, if you can be certain that I'm clamping to something square, then I don't have to worry about like things like over clamping it out of square because my subassembly is square. So that's actually a good way to think about it. Just try to break it down. If you're gluing everything up all at once, you're almost guaranteed to have it come out of square. You're asking for trouble at that point.
Yeah, for sure. I can't tell you how many times for me, it's the opportunity to do a subassembly and sometimes breaking it down to a point where you go, I should really just be able to do this all at once. But if I only have one piece that I have to make sure is nice and square and I could lock that down and get that one, like even if it takes me a little bit longer. Bad example, let's just say you're doing 4 pieces to make a drawer. For whatever reason, you find it like this is going to be daunting to do all 4 of these. You can do one single corner of that drawer. Glue it together, make sure the joints are all pushed together nice and tight, and make sure that is dead square. So now that one can then be a single unit that then you can apply the other to. I'm not saying you should do that with a drawer. Usually you can do the whole thing, but just as an example, I love to be able to take those opportunities to make sure one thing is dead on square to take that stress out of the equation.
That's your reference point for the rest of it. And if you go to Rockler, they have those little right angle clamping, like those little L-shaped clamping guide things.
Yeah, those
there
are
you
good.
go. See, don't say we never did anything for you, Rockler. There's another.
There you go.
There's another product placement right there.
It's quite a one-sided relationship, if you ask me. But no, those are awesome.
There's a lot of little stuff like that, and ultimately it just comes down to like just keep checking. Don't wait until you've got a final assembly and then be wondered what's going on. The last thing I'll say is it's okay if it's out of square. There are some things where there's a lot of fixes to problems that can happen after the fact. He goes on in his question, the part that I didn't read is like, I find that like the legs are never all on the ground at the same time. In other words, you've got that table that rocks. Well, I'll tell you what, like, and he finishes this by saying, one day I'll have a wonderfully square, level, and flat workbench. Don't bother. Because it's not going to do anything good because the floor you're putting that table on is not wonderfully flat and square and and the wood's going to move and it's going to move out of, always know that there's something you can do later. You can level a table later just by trimming the feet. In fact, it's a heck of a lot easier to do that than to try to build it perfectly flat and level, because then you do have to have an assembly table that's perfectly flat and level. And even Mark ditched his assembly table torsion box thing after time.
Yeah, screw that stuff.
Like you're never going to get that right. If you have a case that goes out of square, there are a bunch of different structural elements you can add. We talked about this in the plywood section. If your case is out of square, make sure the back that goes into that case is square. And then, if necessary, wedge it into place so that it fits, and then it will muscle the case into square. Add a face frame, add a cross brace. pull out a block plane and trim just one slight height edge to make that face frame fit better because of that twist. Assuming that everything is going to come out of your shop perfectly flat, perfectly square with no twist almost requires the level of precision we talked about earlier, where your table saw has a computer operated fence and your CNC machine and your planer is digital readout. Like, it's almost madness to expect that we should create this unless we have a $50,000 wood shop. So it's okay. Actually plan for it. And it's amazing what little adjustments. There's a reason the block plane tends to be cited as like the first plane to buy, because it's brilliant for fixing slight out of square things. Your doors don't fit flush to the cabinet, pull out a block plane and plane off the high edges, and only you and your block plane know that case is not perfectly square because the doors fit fine now,
I think this is something that's like an experience thing. It's hard when someone's new, they don't have that experience. So conveying that can be difficult. But ultimately, experience with building things and just learning over time, I know this for me personally has been huge, is knowing what I can get away with. There are things that I should stress about getting perfect. And then there's a lot of other stuff that I know that's where your stress level comes down. I see this with Jason all the time. There are things we'll build together and he'll either make a mistake or something will happen and he gets really upset because he knows it's not correct. But then I'm like, no. This is totally fine, man. We could fix this later. Like, knowing the downstream ways to adjust for something being out of square or being, some sort of inherent error is really comforting. And that is something that will come with the more pieces you build. You'll see what you can get away with not having perfect and what can kind of be pushed off and fixed later on. Because otherwise, if you're trying to make everything, like Shannon was saying, dead on perfect, it's a very unrealistic way to woodwork and it's going to be very frustrating.
I can't do it. I'll tell you right now, I can't do it. So I don't bother. I don't even try. And I think the skill to learn at that point, learning how to fix these little things, that is definitely an experiential thing. But something you can do right now as a beginner is learn to diagnose those issues. And, that's grabbing a ruler. Wow, this is rocking. Okay, well, is this leg longer than that leg? But I milled them all at the same length. So figuring out what's causing that out of square or that rock or whatever. Then once you know what's causing it, then in many instances, the solution becomes kind of obvious. Well, I need to remove a little bit of wood right here. Then it becomes, well, how? Grab a block plane, grab a saw, grab, whatever. There's a bunch of different ways that can be done. And just figuring out what caused it makes it so much easier. And if nothing else, then you learn, okay, well, next time, all of my cases tend to come out of square this way. So next time when I'm gluing one up, make sure that I'm checking that one thing
pay attention
before the glue cures.
Yep, for sure.
Good question, though. I like that question.
Yeah, that was really good. All right, well, I think that's going to do it for us, even though we don't have Matt here. That sucked, but it's still fun. It was kind of nice without him.
He was half here. We went half kimono on this show.
Yeah, his goofy giggles getting in the way. All right. Well, family owned since 1954, Rockler is your go-to source for high quality and innovative woodworking tools, finishing supplies, hardware, lumber, and expert advice. Whether you're building a simple bookshelf, a custom desk, or new kitchen cabinets, Rockler has everything you need to make your next project a success. Visit rockler.com and use the code WoodTalk to receive free shipping on most orders over $49. And remember to head to rockler.com/woodtalk to enter for your chance to win a $250 gift card.
Very nice. Well, you know what? I want to hear from people about plywood because I don't think we've heard enough through Mark's polls. But more importantly, I want to hear good stories about plywood. So both of you, write in and let us know.
I love plywood, let me tell you.
No, but I think importantly, like, what tips do you have? If we just assume that we're never going to get flat plywood, that's fine. Honestly, it becomes very liberating once you accept that fact. So I'd love to hear from people on, in addition to what we've talked about, what do you do? To deal with out of flat plywood, to deal with plywood that's not rigid, because it also plays into our last question here from Jordan on how to make sure stuff is square. So, write us, let us know, send us a voicemail, go to woodtalkshow.com and fill out the contact form, or email us at woodtalkshow@gmail.com, or record a voice memo on your phone and email it to that same place. We'd love to hear it. And Margaret, I know you're listening. Sounds like a good IG post to me.
There you go. I want to know at what point people start to decide maybe I should have gone with solid wood. It's not worth the frustration if you really do need it to be perfect. And
if you're re-gluing your laminations, Mark, now's when.
Is that the time?
That's about 4 or 5 steps beyond when I would say screw this plywood stuff.
That's my high water mark.
Yeah, because when you can just as easily make your own plywood from like your own stuff, yeah, that's generally a red flag.
I mean,
right there.
I didn't get the vacuum press out, so I feel like I was still ahead of the game.
Yeah, that's definitely a red flag right there.
Yeah. All right. Well, thanks for listening, everybody, and we'll catch you next time.
Bye-bye. Somebody giggle like Matt, make it seem like he's still here.
I'm going to tell you guys while we're here something very personal about me. Got a habit.
Got a poop?
Real bad habit. Started when I was a kid. I was always shy about the sound of my urine in a toilet bowl.
Okay.
So you know what I would do to cover it up in those last little drips at the end? I would flush the toilet early because I didn't want people to hear it. I'm 46 years old. I still do it today, and it drives my wife crazy. Because what
I do it just to race it.
Inevitably, I race it, and I don't finish in time, which means I'm either flushing twice, or Nicole gets to see a little yellow mellow going on in the bowl.
I do the same thing, but for a different reason.
Really? You just for fun to race it?
Just for fun.
Yeah. See if I can time it right.
Yeah, and if you go to a different toilet all the time, you can't possibly know all the flush paces of all the toilets.
It's more like pace, like, do I know how much is left in the bladder versus flow rate? Oh, it's a fun
There's
game.
a lot of parts to the process. I mean, it's a lot to think about. So
I don't have a lot of things that like to entertain myself with, so that's like, that's it.
All right, let's do a show.
Can you eliminate any of the foam you create?